So we did, of course, fulfill these requirements. I have now some technical details about how the agent was implemented. Probably these are interested for people working on profilers, but some ideas what exactly was done. First, we buffer the information which is sent from thread. This means that we avoid any locking of the sent information, and we can send multi-records, which reduces the traffic. We have some encoding of the traffic. The memories are located in chunks. We have some customizable hash tables. Actually, the main idea of our approach is that we transfer immediately all information on the network. So we don't collect any information. We collect only the minimum information on the target system. Later I can show you some statistics, but in our case, in the target system, there is very low memory consumption. And only way this to be realized is that you send immediately the profiling information to the profiling application. The price for this is that you must have a good network, but we do it. Nowadays, it's not a problem if you have something like 10 megabytes per second. If you can transmit such kind of information, you have no problems to send all that is necessary in order to have a good profiling environment and not to influence too much the target system. So this is the main thing that we did. In addition to this, of course, a lot of optimizations like this, some encoding, some encoding in this area E, which is pretty simple, but it reduces the traffic 40%. So these are some low-level details. As I say, this is the main point. The minimum information is kept on the agent. Everything is sent immediately to the profiling application. By the way, storing information inside the agent is in many cases slower than sending the information to the network, assuming that the sockets are fast enough and the network is fast enough. And so the last one is to make everything portable. So all machine-dependent code is placed in separate modules. So we are going quite fast for this for different JVMs and operating systems. So key features, I think here there is nothing very special because we support the normal memory profiling, CPU profiling. Everything can be visualized. We support local and remote profiling. It's implemented now as plugin for Eclipse. The project which I'll show to you uses the older version of the profiler, which is standalone. It's a plugin for Eclipse, but this plugin doesn't use the LCP architecture. So you can start it from inside Eclipse, but it's not fully integrated. The new version, which is ready now, is fully integrated with the normal perspectives and views and everything. We can show active total bytes, instances, thread classes. We can start the garbage collection, show the garbage collection activities. There are also some triggers. For example, if something happened, then you can start the CPU profiling. You can easily configure and start and stop for the profiling in special moments of time or when some events happen. For the CPU profiling, it's a standard approach. There are two methods. The timing method, you call a method, you measure the time when the method is, when the call is back. And the sampling methods, these are, we can check the, it's done to track the threads, but by doing samples. So there are snapshots, and then based on some statistic, we can measure the time each method was used. Of course, the second approach is less memory consuming and CPU consuming, but the first one is more precise. You must decide whether precise or without influencing the target system less. So we have full thread dump, deadlock detection, the trigger that I mentioned, keep information, memory stack famous, but these are more or less standard feature. I think here there is nothing much different than the standard profile, but everything is optimized for embedded. And we have some extensions like showing everything per class loader, things which are relevant for OSJ-based embedded system. Now the platforms, as I promised, we support a lot of platforms, which is really the benefit of this profiler. You can see the operating systems, Windows, Symbian, Linux, different big and middle Indian formats, different processors, x86, ARM, MIPS, table continues here, PowerPC, SH4, it's not so popular nowadays, but as you see, practically all reasonable combinations are supported. Supported JVMs. The first one is Sun JDK, IBM JDK, Oracle. These are more enterprise standard JVMs. Embedded are Sun CVMs, Geomir, Onyx, Perk, Esmertech. Some examples, but we have a lot of partners, so we support actually JVMs which support the profiling interfaces which I mentioned. Because if the JVM doesn't have profiling interface, that's difficult. For example, the Javik now for Android, we're working on this. The Javik JVM has very non-standard profiling interface, and some additional work is needed. But for the JVM profiling interface, we support this immediately. All JVMs will provide JVM PI. Okay, now the idea is to show shortly this, but I prefer to finish everything because, as I told you, the demo is showing things here for you. Now, what is interesting is this use case. Recently we were involved in a project when OSGI, embedded framework, embedded platform, was integrated with two mobile phones, mobile devices. One project is the project Sprint Titan. Titan is the name of this platform which is developed for Sprint. This is American operator. And this Titan is available for a set of different operating systems for mobile, Windows Mobile, also for Blue now, and for Android also on this. But I'll show something about this platform. But it's a typical example for complex embedded mobile platform which uses OSGI, and profiler which I'm presenting is included in the development tools which are available for the Sprint Titan developers. They are available also on the website of Sprint. And the second is Nokia for Symbian. There is also an OSGI-based stack, and this stack was also profiled with this profiler. This is, uses the ERCP application model. For you know Eclipse, the ERCP is a way to develop application for desktops, and the ERCP for embedded applications. Why OSGI for embedded? As I said, our company really is quite active in OSGI and using OSGI, so I'll use this opportunity to mention again why OSGI is so useful. Because of what was today, I saw there several presentations about using OSGI in embedded worlds, and it is also about using OSGI. I think OSGI is getting very popular, and I think this OSGI Eclipse is just one of the implementation of OSGI and Equinox, but actually this benefits modularity, dynamical behavior, components, architecture, everything comes from OSGI. So, dynamic components and APIs, there is support for a lot of application models. You can use BT, ERCP, you can directly use OSGI bundles, you can use different application models. There is good security model, user-based, there are a lot of permissions, well-defined. Then there are base services which are available as part of the OSGI specifications. And vendors like Process and also other companies, they have a set of additional services which can be used and can really make the development easy. And the last, there is device management and deployment APIs. And with the time, there are even more and more projects which work on providing deployment and provisioning and management system. Quickly is one example. Recently, there was a project was started in Apache, which is also SAPs. There are also commercial products like products coming from Process.